We've seen that the variance and the standard deviation are extremely important. They measure the dispersion, i.e. variability, variation in a data set. And that's an extremely important thing to know because data sets are not all alike. They're going to vary, and the standard deviation is a great measurement of that variability. But we don't calculate the standard deviation by hand, nor do we calculate the variance by hand. We have calculators to do that if we have a data set given to us. Or you also have to be able to look at computer outputs and figure out where the variance standard deviation are or how to find them from what is given. So let's look here. We have the summary statistics for a random sample of countries that the U.S. exports goods to. So remember, this is the U.S. exports in billions of dollars. These are the countries, but there are a whole bunch of countries that we're not seeing here. That's what the ... is. Okay. So the first thing we want to do is we want to be able to compute the range. Now, if you'll remember, the range is the max minus the min, which in this example is, let's see here, the max was 160.8 and the min was 4.8. So 160.8, that's Canada, 4.8, that's Saudi Arabia. So let's put this back. 160.8, take away 4.8, that would be equal to 156, period. Oops, and I have that in the wrong spot. There we go. Lovely. All right, we've just calculated the range from what was given. And technically it was given over here in the list, but we weren't sure that this was in order numerically, but it was. All right, next, what type of variable or data is the variable US exports? Interesting. And we have to explain our choice. Doubly interesting. Okay, so technically that would be quantitative discrete. And here's why, right? Because money ends, because US dollars end at the penny. They don't have uncountably number of decimals. They have, let me put it this way, US dollars end at the penny, i.e. the 0.01 decimal place. And they don't go any further than that. Since they don't go any further than that, they can't be continuous. Continuous means that if I could just get a finer tuned instrument, I could get more decimal places. But we're not going to get more decimal places out of the US dollar. We stop at the penny, period. So since it has, this means, let me type this up one second. There we go. So if you have a finite number of decimal places, remember that's discrete. If you can't get any more, that's discrete. So like shoe size is an example. Shoe size is discrete because it's 5 or 5.5 or 6 or 6.5 or 7, and that's it, right? Same thing with dollars. There's 100 little sections in there, but that's it. You're not going to get any more than that. You can't go finer tuned than the 0.01 decimal place. All right, so then what level of measurement is that variable? Okay, this is exports. So exports has to be ratio. It's a number and it can never ever be negative, right? Interval will imply you could have negative exports. Now you could have a negative trade deficit. That's different. You could say, hey, we're exporting or we're importing more from this country than we're exporting to. That's possible, but that's not what we're asking about here. We're just asking about exports on their own. And the smallest you can export to is 0. Like I give nothing to this country. Usually a country we have sanctions on. All right, now there are 2 variances given. Where are they? So there's the variance right here, and there's the unadjusted variance. Which is the more appropriate for this data set? Let me circle those 1 second so that makes it a little bit clearer. There we go. I circled them in orange so you can see them a little bit better. So here's the variance and here's the unadjusted variance. Now remember, the unadjusted variance would be sigma squared. So unadjusted variance equals sigma squared, right? It's for a population. And then the variance equals S squared. Okay, so this one is a population variance. Population variance. And this one would be the sample variance. Okay. Now, which one's more appropriate for our data set? Well, our data set was a sample. See how it says up here it's a sample? So the variance, which is, what was it, 1458.3991 is the better measure for our data set measurement of spread, because our data set was a sample, not a population, right? If your data set is a population, then you want to use the sigma one, the unadjusted one, right? But since we have a sample, we want to use the regular one, right? Equals population variance. Just to make that clear. So this is the one we want, right there. All right, now compute the standard deviation. Well, this is the variance, 1458.3991. So since we know the variance is that, and then we know that the standard deviation is the square root of the variance. So that would be the square root of 1458.3991. Approximately. I mean, it's squiggly equals because this is rounded to 4 decimal places. So our answer will be approximately that. And let's go find it. 1458. Okay, so square root is, let me make this bigger so you can see. I want the square root. So that's second x squared button. See above it, it says a little square root. You say 1458.3991, enter. And there you go, 38.189 or so. We're going to round a bit. So 38.189. And there we have it. Beautiful. All right, last but not least, let's interpret the mean and standard deviation in the context of the situation. So we expect that the U.S. exports about, what was the mean? $29.637 billion. Oops, better put a dollar sign in front of it. Billion worth of goods to a country, or any country, give or take $38.189 billion. Now, if you're paying attention, you might realize there's something up with that. So note the range for this. So this gives about, and then let's go find these two numbers. 1 second, let me move this over here. Let me bring up the calculator so you can see what this is. So if I take 29.637 plus 38.189, that's 67.826. So 68 or $67.826 billion. Oh, I should have said on average somewhere. Hold on. We expect that the U.S. exports about, so I said the word about, that's okay, $29.637 billion worth of goods to any given country, give or take $38.189 billion. Sure. About. Right, so it's really important you have the word about in there because it's an average. So this gives a range, here, a range of, and then the lower number would be the second thing, same thing we just did. So second entry, but I'm going to make this turn into a minus sign in the middle. Or you could just type it, 60 or 29.637 takeaway 38.189. So negative 8.552. There we go. Now I'm doing this for a reason because I want you to see something. We said that this data set was was ratio, right? But this guy right here, because that turns in negative like that, that's a sign that something funky is going on. Our standard deviation is actually larger than our average. And when that happens, that's usually a flag of something going on. As long as your data set was ratio, which it is, right? Right. But the lower number is impossible because the data are ratio, right? Level of measurement. So what's going on here? Well, if this happens, if the mean, which was 29.637, take away the standard deviation, yields a negative value, but the data is at a ratio level, which this is, data are, I should say are. The data are at a ratio level. Measurement. Level of measurement, that's often an indicator that the data set was skewed, right? Skewed right or skewed left or something like that. In this case, skewed right. Right, this data set was skewed right. So, and it'll be a sign that it was skewed right. It won't really happen with skewed left because of the way the skewing works and because of where the mean is. But this will happen, and it's kind of one of the reasons that we want to know that we have a ratio level of measurement, because if we start seeing something like this, where 29 take away 38 would get you a negative number, that's usually a cue that this was a right skewed data set. It has actually quite a long tail. Most countries are on the low end, and there are a couple countries, namely Canada and Mexico, that are on the far right end. All right, we're good with that, and we now know how to look at computer output to find all sorts of important information. And that's the kind of question that I love to put on midterms and exams. So I'll see you back here to talk more about the empirical rule.